Hello, everyone. Thank you for joining us today. We are Group 7, composed of Alex Nakla, Sai Suresh, myself, Brian Wiley, and Ryan Foley. And today we're going to be summarizing our final proposal for Team Femur. The purpose of this presentation is to go over and summarize the relevant findings from the work that we have done this semester, all the research that we have done. So the first thing we're going to do is organize our research in a manner that that someone from the outside can look in and understand what the organization is and what the requirements are to, to develop a clear proposal. So we're going to be assessing our data and the strength of our evidence and kind of showing our audience that we have found enough information to make accurate observations. In addition, we're going to be comparing and contrasting the benefits and the negatives of both solution that Team Femur has in mind, and from there we can provide our proposed solution in a clear manner. So an introduction to our team members, we have Alex Nakla, who is our project manager. He has been working closely with the Team Femur programmers and has educated himself with the costs of associated program coding, and which includes man hours and function points and things of that nature. Myself, Sai Suresh, I am a section research lead, and I've been dealing strictly with the HIPAA compliance and the costs and the associated penalties for a healthcare organization as well as an EMR developer if they are not HIPAA compliant. Ryan Foley is the section research lead for the market diagnostics, and he is also going to be getting into the associated revenue and possibly the profit that Team Femur can look to obtain through the two methods. Brian Wiley is our section research lead for cost analysis, and he's going to be dealing primarily with the costs associated where we think that, and which will also be our main determination of which proposal will be better. So Team Femur, just a quick background, is a nonprofit organization that is currently volunteer-based. They have minimal funding right now from grants to keep them afloat. They have a goal in providing continuity and transient healthcare delivery and create a electronic medical record software known as Femur, which allows doctors to take medical data in remote locations. So they need approximately $1.1 to $1.5 million a year to operate full-time, so they're striving for financial viability. And they have two proposed solutions, which is development of a commercial EMR to be used for hospitals and different healthcare organizations, and a medical analytics branch where they will take patient data and try to understand health trends in remote areas and after disaster relief. So just a quick forecast of what we're going to be discussing in this presentation. We're going to be going over for the two proposed solutions, the medical analytics branch, as well as developing a commercial EMR for adoption. We're going to be understanding function point analysis. So here we'll be going over the time per line of code, cost per function point, as well as the man hours required for, say, a software engineer. We're also going to be going over the time requirements. So these are the man hours for the software engineers as well as the administrative workers, minus the debugging and implementing time. We're also be going over cost examination, where are our concerns, and also get into HIPAA requirements and the associated costs with those. And we're also going to be trying to understand who our clients are and our potential market revenue and what the organization can expect to make. And from there, we're going to discuss our evidence from each of the subsections and be able to provide a clear and final recommendation as to what Team Femur should do. So now I'm going to pass it off to Alex Nakla, who's going to go more into functional point analysis and begin his discussion on functional size measurements.
Thank you, Sai. So, to chart out how much time development of an electronic medical record, EMR, software, or analytics branch software would take, we first need to estimate the time required to build the software of interest, which requires that we know how large the systems that we're proposing to build will be. So to do this, we decided on a specific class of software measurement called functional size measurements. So functional size measurements are a method of measuring application size and complexity in terms of the functionalities it provides to its users, rather than the explicit size of the code. So since the measurement is not bound to any existing software, it provides a number of useful advantages. Firstly, we can estimate application size and complexity once we have a list of the functionalities the software has to provide before any software is actually written. This means that our estimation is also not affected by any qualities of code, such as the programming language chosen, programming style, selection of databases and web hosting services that other methods might take into account. There are many types of functional measurements, but for the purposes of our report, we're primarily using the cosmic function point or CFP as we will refer to it. So CFP is an ISO standard functional size measurement, and it's based on the idea that program complexity is a direct result of data movements. So the process to arrive at a count of CFP consists of 3 phases. So the first is the planning phase, where the purpose and scope of the analysis is determined, which helps to establish the context relevant for the estimation. Additionally, since CFP is based on user functionalities, we have to define who the users of the software are so that we understand what providing a particular functionality will entail. Users might be human medical professionals, but they might also be any external software that the software being measured has to interface with. So in our context, this might be a medical billing software. The second phase is a mapping phase. Software requirements are mapped from high-level functionalities to low-level data movements as defined by the COSMIC standard. So first we take these abstract user requirements and then we turn them into more manageable sub-requirements. And then we take these sub-requirements and using the software model as defined by COSMIC, we count the number of data movements that the sub-requirements need. As per the COSMIC method, there are 4 kinds of data movements. There are data entries, where data enters the software system from outside the system. Data exits, where data moves from the software system outside to the external user of the software. And then there are data reads and data writes, where the software system writes or reads data to its own persistent storage, which is usually, in our case, a database. So after the mapping phase, we count the total number of data movements, where one data movement is 1 CFP, and arrive at a total of COSMIC function points. So this count of COSMIC function points, CFP, can then be converted to an estimation of the number of hours required to produce the software. However, there are some important limitations to the CFP method that are relevant to note. So under the COSMIC method, only data movements are considered to contribute to program complexity. So as a result, the size and complexity of the underlying database of the application is not taken into account like it might be in some other functional size measurements, such as the IFPUG function point. Other relevant characteristics not taken into account are the complexity of the algorithms to be implemented, the required quality of code, and the time to re-implement and debug existing and or newly built software. These other weaknesses are not unique to the COSMIC method alone, but rather to most functional size measurements in general, since their focus is on functionality that the user sees rather than what the developer sees. However, there is a workaround so that at least we can consider database complexity in our estimations. We borrow the concept of an internal logical file from the IFPUG function point method. An internal logical file is any file within the system that the system itself is responsible for maintaining. In most modern database management systems, there's a file for each database table, meaning that every table is an internal logical file. Instead of using the IFPUG method points themselves from the internal logical files, we first convert them into COSMIC function points, since research has shown that COSMIC is better at estimating total effort required for web applications, which both strategies will build to some capacity. So having established the process, we can estimate the development time of both of the strategies that Team Femur might deploy. Starting with our analysis of the electronic medical records, we assume that it would be built on top of the current FEMR software, which we roughly estimate at 641.291 COSMIC function points. More information available in our paper and Appendix 1 of our paper. The current software has 109 data tables in its database, and we also assume that application complexity and the complexity of the database are directly correlated. Through an interview with a physician, Dr. Nockley, we discovered that there are 43 healthcare-related functionalities in EMRs that are not in Femur. These features translate into about 135 sub-features, which constitute 406 COSMIC function points, which is a complexity about half that of the current Femur software. Since we assume that the database will also grow as a result of a more complex application, we estimate that 53 new tables will have to be added, which adds a total of 51 COSMIC points to our initial total of 406 points, giving us a grand total of 457 cosmic points, which translates to 360.25 hours of work. For the analytics branch, we first met with Kevin Zurich to discuss what the software would look like. The analytics branch, demarked by the magenta colored box, consists of 7 parts, one of which is human. We assume that for the analytics branch software, an EMR and a hospital database already exist, and our software merely pulls data from it and then pre-processes it. This data is accessible by data scientists who would perform demographic and cost-benefit analyses, and also machine learning models, which would be used to make diagnosis predictions using patient data. For more information on this system, see the software architecture section of our paper and appendices 3 and 4. In total, we estimated that the analytics branch software constitutes 710 cosmic function points, which translates to 554.5 hours of effort. So now I'll hand it off to Brian for a discussion on a cost analysis of both strategies.
Thank you, Alex. For this section of the presentation, I will cover the cost to implement each of the 2 solutions of the project. First, we'll start with the medical branch. To develop the software required, we'll need developers experienced in the medical sector. Currently, there are 2 professional developers with medical experience volunteering for Femur in their free time. We believe that this would be an ideal number of developers working for a startup company such as Team Femur to both accomplish the programming required and to lower cost impact. We've decided to pay these developers at a competitive industry standard wage. We've done this by analyzing the wages of senior developers at competitor EMR companies on websites such as Glassdoor and averaging them to create this number of $91,000. To assist in software development, we have also decided to employ 2 entry-level software development employees at an industry standard wage. Each of the 4 employees would also be provided a workstation laptop at $1,700. This branch would require the addition of a data scientist and 2 data analysts with medical backgrounds. These positions would also provide industry standard wages and laptop workstations. Cover server expenses. Both the analytics and medical branches would require server space to store the data, but the estimation of the data required for such a server or cloud space would require prior knowledge before purchase. In our research, we found that hospitals tend to have about 1 terabyte for text data and about 19 terabytes for image data per year for 250,000 patients. This equates to about 80 megabytes per patient record. This combined is about 20 terabytes of data per year and compounds each additional year. That is, for example, 20 terabytes for year 1, 40 terabytes for year 2, and 60 terabytes for year 3. We also found that the average doctor is visited by 2,400 patients annually. This means that physicians' practices of 5 doctors would require at least 1 terabyte of data. Now on to cloud server prices. Google Cloud Services charge around $21 per terabyte of data per month, with a $46 inventory fee. Using this quote, we found that hospitals would cost around $871 per month and a doctor's office would cost around $87 per month. Here we can see the full expense report table with the developers, data scientists, and medical data analysts' salaries, respectively, at their industry standard wages, the cloud service prices, and the workstation laptops, and then the final prices down at the bottom for the first 3 years. The medical branch the first year would cost $322,000. The addition of the analytics branch would cost $223,000, with the full implementation of the analytics branch costing $545,000. Up next is Sai to speak about HIPAA compliance.
Thank you, Brian, for that thorough summary of the cost analysis for the 2 strategies. So now we're going to be discussing HIPAA compliance. HIPAA is the Health Insurance Portability and Accountability Act, and is mandated by the Health and Human Services, or HHS. So the HIPAA laws are basically requirements to make sure that healthcare organizations and their tools and programs that they use to hold their medical data have the capabilities to accurately and safely hold patient health information, otherwise known as PHI. So they have the authority to mandate penalties for noncompliance and that are around $50,000 per occurrence of noncompliance. So patient health information includes any demographic or personal info for a patient, any of their health records, as well as a payment that they make to their healthcare providers. So legally, the Health and Human Services can either fine for noncompliance up to $1.5 million per year, or they can even issue jail time for occurrences where information is released to people who should not have access, and can also halt operations at this time. So in order to be HIPAA compliant, an organization needs to have 3 categories of privacy safeguards and 254 requirements total. So there's a technical aspect, which includes the backend for the software, and as well as the passwords and restricting access. The physical side, which is mandating the access to people and accountability for the users who input the data. And an administrative, which is mostly post-adoption of an EMR, where the organization is required to have proactive risk assessments available to give to the Health and Human Services to make sure that they're HIPAA compliant. Yeah. So just a quick, in order to become HIPAA compliant, you have to go through an audit. So if Team Femur was to develop and commercialize an EMR, to make their EMR HIPAA compliant, they need to pay $1,000 for an initial audit. For a large organization, which would be the medical analytics branch that Team Femur is proposing, they would need to pay $27,000 to $32,000 for a complete audit. Below is a simple pie chart that gives a price distribution between the different requirements for a healthcare organization to be considered HIPAA compliant. Majority of the cost is the laptop and computers that need to be monitored and make sure the proactive risks are taken, as well as the paper records. The EMR is only a small portion of that HIPAA compliance costs, and this can be used in our discussion. So for a commercial EMR, the focus is in technical requirements. So there's only since there's only $1,000 for a commercial EMR to become HIPAA compliant, they must be able to provide a backend to reduce the risk of hackers, and they must also be able to provide password and data encryption so that only people who require access do have access to the data, and there is no risk of patient health information being released. Through the medical analytics branch, they're going to be having greater responsibilities for compliance that have to focus in the technical aspect, the physical aspect, as well as administrative. A lot of the costs that they may induce are post-adoption maintenance, as well as any issues or penalties that arise from not being HIPAA compliant. In addition, 15% of startup organizations, such as Teamer, fail their first audit, and among this percentage, 5% actually fail the secondary audit. So it may have some difficulty with becoming a HIPAA-compliant analytics branch. So now I'm going to pass it off to Brian, and he's going to be discussing market and revenue research.
Thank you, Sai. Now I'm going to discuss the potential market for both of the solutions. The overall market for both solutions exists primarily in the medical field. But although they both exist in the medical field, the uses of the solutions and the expected revenue of the two are going to differ. The electronic medical record system, or the EMR's primary market, will be hospitals and clinics, which will include doctors, physical therapy clinics, and private practices. The EMRs will allow doctors and other users to provide patients with up-to-date and on-the-spot records, improving hospital efficiency, cutting down costs, and improving patient stay. The use of EMRs will also increase patient safety and security, as all documents will be online. Currently, 83% of doctors use EMRs, and this is only going to continue, as seen in this graph of primary care medical specialists and surgical specialists who were currently using any EMR in 2014. With health providers being the primary source of revenue for the EMR revenue will likely come from a monthly subscription, and this prescription, looking at other existing EMRs, could be anywhere from $565 to $800 per customer per month. So if there was just 30 customers who signed up in the first year, the potential revenue could be around $300,000. So this potential revenue only has upward to go as more and more customers sign up for the program. The analytics branch primary market is going to be healthcare providers and insurance companies, and the benefits that these companies will receive from buying medical analytics include reduced administrative costs and enhanced clinical decision support, leading to an increase in patient health and a decrease in cost. Companies use medical analytics to perform predictive analytics, increasing correct diagnosis and introducing new preventive measures for patients. So by using medical records such as blood tests, prescription records, and hospital visits, they utilize predictive analytics to come up with possible scenarios that patients can face, and they find a way to prevent them. The potential revenue from analytics data is going to come from selling the data to companies. The current global analytics market is worth about $4.64 billion, and this is projected to reach $19.55 billion by 2023. And although we couldn't find a concrete number for the potential revenue of analytics department, we can see that the potential for the money that can be earned is very high. Now I'm going to pass it off to Brian to talk about the discussion comparing the two final solutions.
Thanks, Ryan. Now I'll briefly discuss the results of the research performed by myself and my peers on the project as seen above. 50% of software development is known to be debugging. This is not accounted for in the function point analysis, but may be used in conjunction with it. Using the results of the function point algorithm in combination with the optimum number of developers found in the cost analysis section, we may find that if 4 developers work 8-hour shifts 5 days a week, the medical branch would be finished within 5 weeks, with the completion of the analytics branch taking an additional 4 weeks to complete. Next is HIPAA compliance. HIPAA compliance is not a requirement legally, but is an expectation of EMR services from health professionals. This means that legally, health professionals are the ones responsible for the patient's data, but since they are not developing the software, it is left to the EMR service. It should be noted that less than 10% of EMR services are not HIPAA compliant. Now I'll be talking about the market potential for both the medical and analytics branch. EMR services are widely used in the medical industry. They are an established industry or service with a variety of uses and application. For the analytics branch, there's a $4.6 billion market which shows high potential for this service, but it comes with strong HIPAA compliance and regulation. Up next is Ryan to speak about the final recommendation.
Thanks, Brian. The final recommendation that we're going to propose to Team Femur is to go with the electronic medical record system. The electronic medical record system is the overall better choice of the two solutions. Using the function point analysis, we determined that the EMR system will take around 200 hours less to create than the analytics branch. And the overall initial cost was determined to be about the same for the two, but the EMR was determined to be slightly higher. But due to the possible unforeseen costs through things like HIPAA compliance updates, we decided that the EMR is still the better choice of the two. The EMR system also has had a lot more information on the potential market and revenue. We could determine that the potential market in the medical field will be around $303,000 in the first year with just 30 customers, and we could determine that the potential market for the medical analytics branch had a lot of potential, but we couldn't figure out like a concrete number. So for these reasons, we believe that the creation of a for-profit EMR is the better of the two solutions that Team Femur should implement it. Thank you for taking the time to listen to our presentation. All questions can be directed directly to Alex at his email fv3491@wayne.edu.